Example 4 wants us to solve the system of equations by graphing x plus 3y equals 2 and 3x minus 9y equals 6. Let's go ahead and put these into slope-intercept form. If I subtract x on both sides, I get 3y equals negative x plus 2, and then I want to divide both sides by 3, and we get y equals negative 1/3 x plus 2/3. And if I subtract 3x from both sides in our second equation, I get negative 9y is equal to negative 3x plus 6, and then I want to divide both sides by negative 9, and that will give us y equals 1/3 x minus 2/3. All right, let's go ahead and graph these. So y equals negative 1/3 x plus 2/3 has a y-intercept of 0, 2/3. And then I'm going to move down 1 unit and right 3 units. That's going to be about right there. Okay, so it's going to look something like that. And then the other line has a y-intercept of 0, negative 2/3 and a slope of 1/3. So I'm going to go up 1 unit, right 3 units. Okay, and then that's going to look something like that. And the point of intersection is right there. Now, it's not super accurate, but I'm going to say 2, 0, but it looks like that could potentially be an incorrect answer. So let's go ahead and move through using elimination just to be certain that our answer is correct. So I'm going to multiply this top equation by 3, and if I do that, we get 3x plus 9y is equal to 6. And I'm just going to copy over the bottom equation, 3x minus 9y is equal to 6. Now, if I subtract these two equations, 3x minus 3x is 0, 9y minus negative 9y is 18y, and 6 minus 6 is 0. So we get 18y is equal to 0. I'm going to divide both sides by 18. And we get y is equal to 0 divided by 18, which is just 0. And look, that does match with what I guessed my y-coordinate to be here, but let's go ahead and plug that into the first equation. So we get x plus 3y. I'm going to replace y with 0. And 3 times 0 is 0, so I get x plus 0 equals 2. And that is just x equals 2. So that matches with what I guessed earlier based off of the graph, but it's nice that we just make sure. So our final answer is 2, 0. Let's move on to solving systems of equations by using the elimination method. So this first example, we have 2x plus y equals negative 3, and 3x minus 2y is equal to negative 8. Now, you can multiply whatever you want as long as both equations end up having the same coefficient, so that when you add or subtract the two equations, one of the variables is eliminated. But for example, I could multiply this by 3, and I could multiply the bottom equation by 2, And if we did that, I'm not going to multiply everything out, but the first term would be 6x in the first equation, and in the bottom equation, that's going to be 6x. But that's going to be more multiplication than I really have to do, because notice that if I multiply the top equation by 2, that's going to give me 4x plus 2y is equal to -6. And I don't need to multiply the bottom equation by anything. Because notice, now if I add these two equations together, 2y plus -2y, those will eliminate each other. And we get 7x is equal to -6 plus -8 is -14. So my suggestion is, do whatever you'd like as long as you're able to understand that you can multiply the equations by whatever as long as you can eliminate one of the variables. But for me personally, I'm trying to do as little work as possible, so I want to be strategic about what I'm multiplying by. So if I divide both sides by 7, I end up getting that x equals -2 here. And now I can go ahead and plug that in to either of the equations. I'm going to plug it into the first equation. So we have 2 times -2 plus y is equal to -3. Multiplying those two numbers together, I get -4 plus y is equal to -3. And then if I add 4 to both sides here, we get y equals 1. Now, I'm going to plug both of these x and y values into the second equation just to double check that I'm doing this correctly. So I have 3 times -2 minus 2 times 1. And if I do this correctly, my answer should be -8. So let's see, 3 times -2 is -6, and then -2 times 1 is -2, and those will combine to become -8, which is what I wanted because that's the value that we see in that second equation. So therefore, my final answer should be the ordered pair -2, 1. And I'm going to go ahead and box my final answer there.